Okay, well, the last video did get stopped. I ran out of time, so my apologies. Okay, so we were on example 2, and we were saying that they asked for f at -3, which means they just want us to take -3 and plug it in for x and see what our result is. So that would look like this. We're going to, every time you see an x, I'm going to write the entire thing out. Every time I see an x, I'm going to leave a blank, and I'm going to come back and fill in a -3. -3. Okay, and so when I do that, what's going to happen is I'm going to punch this all in the calculator, and my result is going to be f at -3 equals a -137. Yes, that's right, folks. It's weird, strange value. We don't usually get big values like that, but it's true. Remember, this is just a shortcut to synthetic division. I could have come over here, done synthetic with a 1, a 0, a -2, a 7, a 0, and a -11. I could have gone through this. Remember, the 0 is because there's no x to the 4th in this function, and there's no plain x to the 1st power in this function, so I had zeros in their place. If you go through it, your remainder down here will be -137. This is just a time saver and a shortcut. Okay, so it says, remember that the remainder theorem is just a way to find the remainder that much quicker. Okay, so moving on then. On the right-hand page of your notebook, which is page 66, we'll have these 3 copied down already. I hope you should have paused the video on the last time. And so it says use the remainder theorem to find the remainder of each. So what that means is they don't want synthetic division. They really want us to learn and use that new theorem, the remainder theorem. So first of all, we know that we're going to be substituting a value in to this big equation. This is the potential factor here, and remember we always set it equal to 0 and solve, because we want to use whatever value would make this equal 0. So we'd have to solve, add 1 on both sides, x equals 1, so the 1, the positive 1, just like with synthetic, you want to find what will make this equal 1. I'm sorry, 0, and that would be a 1 in this case. So now I'm going to take this entire function. I like to write it all out and then just kind of come back and plug in the number later. Okay, and when you do that, you plug it in your calculator, and as you know, I am plugging it in to mine. I do have a calculator off screen I'm using just because it's a tiny bit quicker. You should be plugging it in yours, and I get a 0. So all of this equaled 0. Okay, so that means our remainder is 0. If we got this, evaluated this function at 1, and it gave us a 0, then the remainder is whatever this equaled. So it was also 0. And that's all that the remainder theorem says. Shortcut to find the remainder. Okay, next one, same way. We're going to set this bottom equal to 0. This is a potential factor. We don't know for sure if it's a factor, but they're giving it for us to use for division. And we're going to solve, and we're going to get x equals -2. So I'm going to write this entire function using the remainder theorem, not synthetic division. I want to arrive at what it equals, because remember, whatever it equals is also our remainder. Okay? So again, off screen, I am using my calculator, and you should try yours. You're probably even faster than me at this. Okay, I got a remainder, or I got an answer of 6. So this evaluates to equal 6, and therefore, because of the remainder theorem, it says this answer is also our remainder. So our remainder is 6. If I did synthetic division using a -2 and this function, don't forget you'd fill in a 0 for the x to the 1st power because it's missing. You would get 6 as a remainder. All right, last one. This one, a little more complicated, but not too much. Just remember you got to set it equal to 0. So the first thing you would do would be add 1 on both sides, and you'd get that. And the next thing you would do would be divide by 2 on both sides. So you're actually going to use a 1/2 as you plug in here. So it's actually way easier to use a 1/2 with plugging it in as a remainder theorem problem than it would be to have a 1/2 and do synthetic division. That could get kind of messy. Okay, so here we go. And I want to know, what does it equal? Because whatever it equals is also just happens to be our remainder. So this one is kind of hard to believe if you don't see it, because it looks like it's going to be something pretty crazy, but it's really not. So 2 parentheses 1 divide 2, remember, is how we write a fraction in the calculator. One of the ways, especially if you have an old calculator like mine. And there's 1/2 and plus 5. So that's my function there. And wow, we got 0. So if 0 is my answer here, then the remainder theorem says 0 is also the remainder. Bam. Okay, so here are just a few that you can try. I wouldn't even say write them down. I'd say just grab your calculator, and they're already telling you to plug in a 2 into this function. They're already telling you to plug in a 2. Plug in a -3, plug in a -2. They've already set it equal to 0 and solved it. You just have to now use this number, plug it in, and evaluate. So take this function, plug in a 2, make sure you do a negative and then the parentheses, and then the 3 outside. So the negative and the 3, third power, are outside the parentheses, and the 2 is the only thing inside. Okay, so pause the video, just type a couple of them, pick a couple random ones on this screen, type them in, give them a try. Okay, so if you did that and paused the video, I'm now going to show you the answers. So whichever couple that you did pick, you can just check their results here. This is what I got. If I made a mistake, my apologies. I am doing this at almost 10 o'clock at night with a fever, so I'm doing my best, but I'm sorry if I made a mistake. I thought I double-checked them. So, but you get the point. The point is that we're going to need to know remainders without having to do synthetic division. This is a shortcut way to do it. Okay, so this is the end of the remainder theorem. It's going to come up again in the next video, so this will be the third and hopefully one of the final videos. It might take me 2 sections again for the next one. We're going to do the factor theorem next, but this literally is all there is to do on the remainder theorem. There's not even any homework on it. So I want you to make sure you have all these notes and everything copied. This screen in front of you, you don't have to have copied. It was just something to type in your calculator for practice to reinforce the remainder theorem. Okay, so you're going to be doing a couple warm-ups for the factor theorem. You don't have to write them down, just kind of follow along with me in the next video. And then we'll be back in that same little foldable booklet on page 65 that has the factor theorem in it. We will do the notes, and we will do a whole page of example problems, and then you will have homework after that. All right, so tune in to the next one.